In this video, I will explain you about Zener diode. Now we will see what is the application of Zener diode. See, Zener diode is one of the application of PN junction diode. So Zener diode is simply a PN junction diode, and we will see for what application we will use Zener diode. See, Zener diode is used for the regulation of voltage supplied. This is a highly doped PN junction and it is connected in reverse bias. So these points are very important. Reverse bias, highly doped, and it is used for regulation of voltage. Now, let's say we have a TV or a refrigerator, and that should be continuously supplied with a voltage of 220 volt. But you know, due to many factors, the power supply may subject to variation. That is, the supply given to our house may change its value in between 220 to 240, maybe higher than this. So this will be the supply to our house would be subjected to variation. But this variation should not be applied across refrigerator, because we need a constant voltage of 220 volt to be applied across refrigerator. If there is a voltage variation, then that will damages the component of refrigerator. Now, from a varying input, how to get a constant output? This we are going to see in Zener diode. So first I will give you an explanation, a very simple analogy in the case of a water level. Let's say we are keeping a water level at our room. So I am sitting near to a table and I have a water level here. And I want this water to be maintained at a constant level. So let's say this is the level. And this water is connected to a tank. So I am doing an experiment. I need a constant water level here. I have connected this to a tank. Now there is a valve connected here. So I have connected the valve, and I have connected the valve. Now I have opened the valve. I have maintained a water level here. But let's say this level has got, this valve has got some leakage. So whenever there is leakage, what will happen? This would subject to variation. So if this is varying, as a physics, I mean person who is doing experiment, I will have a different value of water level which I can't accept. Okay, now what I will do, I will provide one more pipe here, and let's say I have to maintain a level of this much. This is the level I need to maintain. So what will I do? I will make an open tube here. So whenever water is being filled here, water will also be filled here in this pipe with the same height. Now let's say this has got some leakage, and with the leakage, water is going through the pipe. What will happen? Now the same amount of water will go here and will go here. Now we know that whenever there is 1 centimeter rise here, and 1 centimeter rise would be here as well. So let's say this is at 1 meter, this would be at 1 meter. If it is at 2 meter, this would be at 2 meter. Now what will happen? Now when water is going through this pipe, that water will go to both the pipe, but in this pipe it cannot rise its height, because this is an open pipe. When the water comes into the pipe, that will spill out. Okay, that will fall out. So what will happen? There won't be any change in the level of water in this pipe, so that this would be maintained at the constant water level. See, once again, if water comes in, let's say for water equal to water in such an amount that can change the level by 1 centimeter. If it comes in, then for 1 centimeter rise here, water should rise by 1 centimeter here and also by here. They both have to happen, then there won't be water rise. But for here to water rise is not possible. because it's an open pipe, water will come out, so water will never rise through this pipe. This will always be maintained at a constant level. Now here if I want to maintain a constant water level of this, what I will do, I will raise the height of open pipe to this much. Now the water will be filled in both the pipe. Any leakage that comes, that will go out through this, maintaining a constant water level here. So this is just an application. Now you have seen that whatever may be the amount, this would be maintained at a constant level. Okay, so this is just for the concept clarity. Okay, now we have learned a PN junction applied with reverse bias. Okay, a PN junction when it is applied with a reverse bias, negative and positive, we know that the characteristics would be in this way. There would be a small amount of current initially, and after certain point breakdown will happen. Now see, after this point, can you see one thing? Current is increasing exponentially, but the voltage is kept constant. See, let's say 100 volt is the breakdown voltage. After 100 volt, we can't increase the voltage across this Zener diode, sorry, the PN junction diode. 100 volt is the breakdown voltage, say for example. So till 100 volt, from 0 volt till 100 volt, we are able to increase the external potential. Now after 100 volt, if you are increasing, what will happen? Let's say this is 120 volt, but this additional 20 volt will be a result, will be a cause for the exponential current. But on sending the exponential current, this would maintain a constant value of 100 volt. So if you are giving 120 volt, what will happen? Here it would maintain constant 100 volt. If you are giving 150 volt, what will happen here? The potential difference across this, it will maintain at breakdown voltage, and the effect of at excess 50 would be simply a exponential increase in the current. Okay, how is that possible? We have learned that terminal voltage is equal to E minus IR. Okay, now the terminal voltage is, say for example 100, and the EMF we have applied is 120, and internal resistance, here it is, say for example 20. So internal resistance is for example 2. So what will happen when the internal resistance is 2? It will send a current of 10. So that 10 multiplied by internal resistance would be 120 minus 20, which is 100 volt. Now if you are increasing the EMF of the cell into a next value, which is 140, what will happen? This internal resistance is 2, so that the current will become 40. Now current will increase to not 40, 20, so that the next net terminal voltage would be 140 minus 40, which is 100 volt itself. Next value I am increasing into 160. Okay, so if I am increasing to 160, what will happen? The current in the circuit change, so that 160 minus current will become 60 have to go, yeah, 30 into 2, which is 60. 160 minus 60 is 100 volt. See, we are able to get a constant voltage or potential difference across this PN junction diode at breakdown voltage. So my concept is very simple here. Whenever we are increasing the EMF of the cell or the supplied voltage, what will happen across a PN junction diode when it is connected in reverse bias and at breakdown voltage? Whatever may be the value, this will maintain its terminal voltage as the breakdown voltage. Any increase in the supplied voltage would send more amount of current through the circuit, so that it will maintain a constant terminal voltage. See, I have explained. I have applied 120, 140, 160. the change is initially 10 ampere current, then 20 ampere current and 30 ampere current, and it adjusted itself for a constant terminal voltage across the Zener diode, across the PN junction diode. Now this PN junction diode can be called as Zener diode when it is highly doped, and this diode has got a terminal voltage, has got the breakdown voltage as the voltage required to maintain here. For example, I need to maintain a constant voltage in refrigerator which is 220 volt. So I will choose a Zener diode that has got its breakdown voltage as 220 volt. Okay, so this is a highly doped PN junction diode. What will happen when I am applying 240 voltage here? So when I am applying 240 voltage, so I am applying across these 2 points. So what we are expecting, the same 240 volt will go here, but that is not what actually happening. When 240 is applied here, it would send more current and it would adjust the terminal voltage as 220 volt. Now if I am increasing the value to 260 volt, what will happen? The current through this would be increased to a new value so that it will maintain a constant voltage of terminal voltage of 220 volt. Now this voltage would be applied across the load. So whatever the voltage that Zener diode is keeping in between its end would be the voltage or potential applied across the load, either TV or refrigerator. So this is a stabilizer, this is a regulator. Whatever may be the voltage applied, Zener diode would adjust itself to a constant value. The value is nothing but breakdown voltage. How would it adjust? By sending more amount of current through Zener diode, it would keep a constant terminal voltage. Thereby it delivers a constant or it regulates the supplied voltage. Okay, this is very important with this relation, and this is the graph. Okay, this is the graph, and here it should be in forward reverse bias, positive to negative and negative to positive, and this is the load. Okay, thank you.